Hey everybody, I'm going to show you how to graph some of these functions in your calculator. Of course, you should be doing them by hand as well, but some of these can get a little bit tricky. So if you have one of these log bases that's not a natural log or a log base 10 and you have an older calculator, you're going to have to use the change of base formula. So I have the older TI-84 here. If you have a newer TI-84, you can click on math, and I believe that there is a log base down here towards the bottom, and that'll allow you to put in different log bases. However, on the older ones that doesn't exist, so I'm going to show you how to do this on an 83 or 84. This will work on the newer ones as well. So what we're going to do is for log base 2, if you want to check out this on the graphing calculator, we need to do a change of base formula. So if you don't remember how to do that, you can go back and look at the previous section where we talked about change of base. But you should know that the change of base for log base 2 of x, that's just going to be natural log of x divided by natural log of 2. You could do that with the, another way to do it would be with the log base 10. So you could do log base 10 of x divided by log base 10, the common log of 2, and that should get us our graph. So, but I think it's easier just to use the natural log. They're about the same really, but then we can graph it and we can kind of get a look at it. It's not going to graph the asymptote. There's an asymptote here at x equals 0. When you zoom in on this, just because of the, just kind of the pixelated nature of these calculators, you're not going to see really where the asymptote is, but you can kind of imagine that this line is the asymptote right here. You can do the same thing if you needed to graph one of these with the negative in front. You should know that the negative in the front, that's going to reflect it over the x-axis. But here I could do like negative natural log of x divided by the natural log of 5. And then that should get us our graph. Let's go back here to the zoom standard. Yep, and then again that there's an asymptote right here that's kind of hard to see on the calculator. But if you zoom in, you can imagine that there's a vertical asymptote here, and this line is getting infinitely close to it. So whenever you have one of these as a fraction, that's going to be a little bit trickier. When you have a fraction as the base, the log function, like the general log function, is going to look a little bit different. It's actually going to invert. So there's kind of a reason for this, and I'll show you. So what's going on here is that if you think about this function y is equal to log base 1/5 of x, if you rewrite it in the exponential form, you can think of it as 1/5 raised to the y power is equal to x. But 1/5, you could also think of that as, I can kind of show you the intermediate step. 1/5 you could think of as 5 to the negative first, and so all of that will be raised to the y power. But there's a rule with exponents that when you take a power raised to another power, you end up multiplying these two together. So you'll get -1 times y, and that will get you the negative y right here. So really 1/5 to the y power is really the same thing as 5 to the negative y. Then if you go back and rewrite that back in the log form, now it's log base 5 of x is equal to negative y. And then of course you can just divide both sides by -1, and that'll give you that y is equal to negative log base 5 of x. So it turns out that these two graphs will actually be equal to each other. So you can kind of see that too if you graph one of these. If I could just graph this using the change of base, doing natural log of x divided by natural log of 1/5. And you can see we get a graph that looks like this. Again, it's kind of hard to see. Let's zoom in real quick on the middle. Here's the asymptote here. The other thing you can think about is like, where is there a nice point? Well, if you're looking at 1/5, log base 1/5 of x, the nice point is going to be at x equals 5, because if you have log base 1/5 of 5, you're really asking what power should you raise 5 to in order to get 1/5. And that's a nice number. That's a -1. 5 to the negative first power is 1/5. And you can see right here at x equals 5, here's y equals -1. And you'll be able to see that on the graph over here. Likewise, you could have also graphed it like this. Algebraically, they should be the same. So you get negative natural log of x divided by natural log of 5. And you'll see we end up with the same graph here. And again, there's that point here at 5, -1. So that's a nice way to deal with these if you want to look at them on the calculator when they're not natural log or the common log. You can always just do those change of base formulas and use the natural log to graph them. So hopefully that's helpful. Let me know if you have any questions about this.